Not proof. But it is a door. A door we've never opened before. What might we find behind it? Could K2-18b be our first hint that the universe is alive? Could its oceans hold ecosystems we can only imagine? Could this be the beginning of something bigger? A cosmic awakening? We are entering an era where the search for life is no longer science fiction. It's science. In the coming years, more telescopes will rise. New missions will launch. And worlds like K2-18b will come into sharper focus. We'll search for seasonal changes, cloud patterns, heat signatures, even the glint of oceans under alien suns. Because now, we know what to look for. We know what the fingerprints of life might feel like. And they are unlike anything we expected. K2-18b has become a symbol. A distant world, reminding us that the universe may be filled with places where life could bloom. It may not look like us. It may not think like us. But it may be out there, watching its own skies, wondering if we exist too. In a universe of billions of galaxies, with trillions of planets, how could we be the only spark? K2-18b doesn't give us an answer. But it gives us something just as powerful. A reason to keep searching. A reason to keep listening. Because maybe, the universe isn't silent. Maybe it's been humming with life all along. And we've only just begun to hear its song. In the cold void between stars, planets drift in silence. But silence does not mean emptiness. We used to believe life could only exist on planets like Earth. Rocky. Warm. With blue skies and green trees. But now, the universe is revealing something far stranger. Oceans without land. Skies thick with hydrogen. Worlds lit by red suns. Worlds like K2-18b. And maybe, they're alive. These aren't desert planets or frozen wastelands. They're warm, they're wet. And they're everywhere. Hycean planets, once just theory, are emerging as common across the galaxy. Billions may exist. Some orbit stars smaller than our sun. Dim red dwarfs that burn for trillions of years. Longer than life has even existed on Earth. That gives life time to grow. To evolve. To build worlds we've never imagined. So, what kind of life could exist on a Hycean planet? Without solid ground, there are no forests. No deserts. No mountains. But there is ocean. Deep, endless, alien ocean. Dark waters beneath a pink hydrogen sky. Here, light barely penetrates the surface. And yet, life may thrive. Not with chlorophyll and sunlight like on Earth. But with chemistry. Hydrothermal vents may churn at the bottom, releasing heat and minerals. Just like Earth's own deep sea vents, where strange creatures thrive in eternal night. Giant tube worms. Crabs with no eyes. Bacteria that eat sulfur, life that doesn't need sunlight. On K2-18b, this could be the norm. Not the exception. Or perhaps, life there has adapted to float, buoyant organisms drifting through the upper clouds. Feeding on trace chemicals in the atmosphere. Tiny hydrogen balloons, like jellyfish, drifting in alien skies. Living clouds we can only guess. But what's no longer guesswork, is the possibility. The chemicals we've seen, dimethyl sulfide, dimethyl disulfide, don't appear by accident. Something must be creating them. And if it's life, then K2-18b is our first real glimpse at biology beyond Earth. That changes everything. It means biology isn't a miracle. It's a pattern. It means we're not the universe's 24 light-years is impossibly far with current technology. It would take thousands of years to reach with today's fastest spacecraft. But time is on our side. And so is innovation. New propulsion ideas are emerging, fusion drives, light sails, antimatter engines. One day, they may allow us to touch alien oceans with robotic probes. Or even send messages, simple pulses of light, to say, "We see you. We know you're there." But we don't have to wait to dream. Already, Earth's telescopes are evolving. The upcoming aerial mission, launching in 2029, will scan hundreds of exoplanet atmospheres, including Hycean ones. It will refine our understanding of alien chemistry and climate. Then, in the 2030s, NASA's Habitable Worlds Observatory will launch. It won't just observe planets. It will image them. Photograph them directly. See their weather. Their cloud bands. Their seasons. Their reflections. Imagine looking at a real photo of K2-18b, oceans glinting in red starlight. Not an artist's concept. A real, alien world. But the vision doesn't stop there. By the 2040s and 50s, we may launch LIFE, the Large Interferometer for Exoplanets. A space telescope so advanced it could map alien continents and oceans. Watch planets spin. Watch clouds shift. Watch alien days and nights pass, in real time. We may even detect signs of vegetation, if it exists. Not green, perhaps. But maybe purple. Or black. Or colors we've never seen before. Because alien life won't follow Earth's rules. It will write its own. The future of astrobiology is no longer limited by imagination. It's fueled by data. By telescopes. By the whispers of molecules in alien skies. And every time we find another world like K2-18b, the whispers grow louder. Together, they form a cosmic song. Not of emptiness. But of potential. Of life not as we know it, but as it truly may be. A universe alive. And one day, when we look back, we may realize that K2-18b wasn't just a planet. It was the first verse of a story still being written. The story of our connection to the cosmos.